When conducting a formal hypothesis test to determine whether there is a significant linear correlation between two variables, we can use the following null and alternative hypothesis that use P, which is technically called rho in this case, but we can just say P, to represent the linear correlation coefficient of the population. So the null hypothesis, P equals 0, we say there is a no linear correlation, and then the alternative hypothesis, P does not equal 0, there is a linear correlation. Now, like with other hypothesis tests, you can determine if there is a linear correlation by using either the critical value method or the p-value method. For this video, we are going to be using the p-value method. Using the p-value method means we will compare p and alpha, just like we normally do. These are the two possible results of that. If the p-value is less than or equal to alpha, it supports the claim of a linear correlation. So if the p is low, we reject the null, we reject that, and we say there is a linear correlation. Or the p is higher than alpha, which does not support a claim of a linear correlation. So if the p-value is higher than alpha, we fail to reject. So if we fail to reject, we say there is no linear correlation. That's how that works up there. Another useful piece of information from the hypothesis test is the value of the test statistic t. You can find it using technology, but if the formula for the test statistic is this, r over the square root of 1 minus r squared over n minus 2. N being the number of pairs of numbers. There are some requirements that need to be followed when conducting a hypothesis test to determine linear correlation. They are the sample of paired XY data is a simple random sample of quantitative data, which we usually will default to that. Otherwise, not really going to be able to do it. A visual examination of the scatter plot must confirm that the points approximate a straight line pattern. And because results can strongly be affected by the presence of outliers, any outliers must be removed if they are known to be errors. So if you see something that's out of the ordinary and you know it's wrong, get rid of it. Now, as always, we'll be using our calculator to do the majority of the work. Now, when doing the hypothesis test, you want to use in your TI 8384 calculator, linreg t-test. So, let's look at an example. Listed below are repair costs in dollars for cars crashed at 6 miles per hour in a full frontal crash test and the same cars crashed at 6 miles per hour in a full rear crash test. Determine whether there is sufficient evidence to support a claim of a linear correlation between the two variables, and we are going to let alpha equal 0.05. So first thing I'm going to do is I am going to put all my values into my calculator. So I'm going to bring up my calculator here. Now, there it is. And I am going to put all my values in. So again, stat, one edit, and there are all my values. Just make sure they're typed in correctly when you do that, but I've already typed them in ahead of time. Now, we're going to assume that it's a simple random sample because that's what the requirements, oh, there it is. Simple random sample of quantitative data, so we're going to assume that. The only thing we're really going to do here is we're going to do a visual examination of the scatter plot and confirm that the points approximate a straight line pattern. So I'm going to hit second y equals, turn on my scatter plot. So turn it on, make sure it's on here, L1 and L2. I'm going to use little boxes. Then I'm going to go to zoom, and I'm going to go down to zoom stat. Hit enter, and there it is. It doesn't look good. It's kind of all over the place, but it's okay. We're gonna see how it works out. So I don't see a straight line pattern here, but let the math do the work for me. So first off is I'm going to set up my hypothesis test so I know what it's going to be. So I know that H sub naught is going to be rho equaling 0 or P equaling 0, and the alternative is going to be not equaling 0. And we know that alpha is 0.05. We've already put everything in to the calculator, so let us, use the calculator. So I'm going to go to stat, over to tests, and I want linreg t-test. So linreg t-test, just like I said, you're going to hit enter, and you're going to be given these prompts here. So x listed as L1, y listed as L2, and it should be defaulted to not equaling 0 for p. So just scroll on down to calculate. It's going to think about it for a second, and we're going to get some values here. So we see that t is negative 0.66. So I'm going to say that my test statistic t is negative 0.66. I'm going to say that my p-value, again to 4 decimal places, is 0.5392. 0.5392. See here, what else do we got? So we can scroll down. We even got the linear regression equation. We got a and b right there, so we can write out what a and b are for our equations. So we can say that y equals 2062.61 minus 0.19x. If you need the equation, it's given to you. You can even scroll down and get your R value as well, which is negative 0.2826. So R is equal to negative 0.2826. So we have everything we need for the p-value method. Again, I'm going to compare my p-value to my alpha value. So 0.5392 is greater than 0.05. Since it is greater than, we can say that we fail to reject the null. Now, it's not enough to just get this information. You actually got to type out a conclusion. So that's what we are going to do now. So we can say that there is not sufficient evidence to support the claim of a linear correlation between the repair costs from full frontal crashes and full rear crashes. Put that in red and bold it so it's a little bit easier to read. There we go. And there is our hypothesis test done. We got our test statistic t, p-value, got our linear regression equation, and r value if we need it. We used the p-value method, so we compared the p-value to the alpha value. We failed to reject. We said there's no evidence of a linear correlation. The graph showed that as much as well. So the graph showed it. The evidence here showed it. So everything says that there's no linear correlation. So I feel pretty confident that there is none. And that's how you do it. Now, let's see here. Let's do it again, but this time we're going to do this information here. So what do we got here? Listed below are combined city highway fuel economy ratings in miles per gallon for different cars. The old ratings are based on tests used before 2008, and the new ratings are based on tests that went into effect in 2008. Determine whether there is sufficient evidence to support a claim of a linear correlation between the two variables. Again, we're going to let alpha equal 0.05. So we have our old, our new. Old will be x's, new will be y's. So again, we are going to set up our hypothesis test again. So h sum naught, p equals 0. Alternative hypothesis, p does not equal 0. And we know that alpha equals 0.05. Never hurts to just write it out. So let's bring up our calculator back. We need it, so there it is. And we're going to put in our values into our list. So we're going to go to stat, one edit, and like magic, there are all the numbers already put in. So again, always double check that it's good. And I already know that my stat plot is on, but again, second y equals just to confirm that it's good. Hit enter, again, it's on there, all is well. Go to zoom. We're going to go to zoom stat. And I see a kind of a straight line. Something looks pretty good. Again, that makes me feel good that it is a straight line, but I need more information. So I'm going to plug it into my calculator. Well, let my calculator do the work since it's already plugged it in. So we're going to go to stat, tests, And I'm going to go to linreg t-test. Everything should be as is. Down to calculate, thinks about it, gives me an answer. And what do we have here? We have a test statistic t of 47.46. We have a p-value that is to the negative 12th power, so that's pretty small. So let's see here. T equals 47.46. That's really large. P is essentially 0. What else do we got here? We can get our equation. So 0.81 and 0.86 for A and B, just plugging them in. So y equals 0.81 plus 0.86x. And I think we can do a little bit better. We can go get our R value while we're here. R is 0.998. And now we're going to compare our p value to our alpha value. So 0 is less than or equal to 0.05. Since the p is low, we will reject. And since we are rejecting, what does that mean? We can say that there is sufficient evidence to support the claim of a linear correlation between the old and new fuel economy ratings. There we go. Bold it, make it red. And there it is. Nice and easy. So there's our information for this problem here. We have all of the evidence given to us. We got our hypothesis test set up. We got the test statistic p-value, equation if we need it, the R value if we need it, but we're just doing the alpha value compared to the p-value, or p compared to alpha, excuse me. Since the p is low, we reject, and since we're rejecting the null hypothesis, we say that there is sufficient evidence to support the claim. And this is how you would find or test hypothesis test for a linear correlation between two sets of values using the p-value method.